Assalamualaikum warahmatullahi wabarakatuh. My name is Afi Min Bikhair Aznam and my match number is 9200250. Okay, so I'm from group 3 and I will present about hydrocarbon. So, firstly, this is our group members. For the first question, the question asks to draw the structure JKLM and N and explain my answer. So, J is 2-methyl propene, K is 1-butene, L is 2-butene, M is cyclobutane, and N is methyl cyclopropane. So the question also asks me to explain my answer and explain why J has the lowest boiling point. So is J, K, and L react with bromine CH2 Cl2 in that condition. Only alkane can react with it, so J, K, and L are alkane. Meanwhile, M and N are cycloalkane. Alkane cannot react with CH2 Cl2 in that condition. So next is why J has lowest boiling point. It is because van der Waals forces are very weak in J. 2-methylpropane has lower boiling point because the dispersion forces are weaker. The molecules are shorter and fatter, make it a very low boiling point.
The two isomers that give active product. One, name 1-butene. 1-butene react with hydrogen bromide will form 2-bromobutane, which is the major product, and 1-bromobutane, which is the minor product. Second one, 2-butene. Question: 2-butene will react with hydrogen bromide, will form 2-bromobutane. Okay. So for the mechanism, for 1-butene is electrophilic addition. Step 1, addition of an electrophile. When the polar hydrogen bromide approaches 1-butene, the pi electron of the double bond will attack the positively charged hydrogen ion H+, and will be polarized. Then, the hydrogen will make a bond with the carbon that is attached with most hydrogens, which follows Markovnikov's rules and cause the other carbon to form carbocation. This process also causes a nucleophile. Step 2, formation of product from the carbocation. The negative charged bromide ion Br- will attack the carbocation and forms a bond. The major product that is formed is 2-bromobutane and the minor product is 1-bromobutane. Okay, next. For 2-butane, electrophilic addition. Step 1, addition of an electrophile. When the polar hydrogen bromide approaches 2-butene, which is symmetrically molecule, the pi electron of the double bond will attack the positively charged hydrogen ion H+, and will be polarized, and the hydrogen will attach to one of the carbon and cause the other carbon to form carbocation. This process also causes a nucleophile Br- to form. Step 2, formation of product from carbocation. The negative charged bromide ion Br- will attack the carbocation and forms a bond. The product that forms is 2-bromobutane. Okay.
Warahmatullahi wabarakatuh. My name is Ahmad Zafar Ifan Birazi. My nomenclature is 9200265. So my question is, give a chemical test other than bromine in CH2Cl2 in the dark to distinguish between J and M. So firstly, we use combination test. J C4H8 will react with 6 mol of oxygen gas O2 and produce 4 mol of CO2 carbon dioxide gas and 4 mol of water H2O. So the observation is, first, the color of the flame is blue, and second, more solid is formed. Next, we use M C4H10 will react with 9/2 oxygen gas, mole of oxygen gas, and it will form 4 mole of CO2, carbon dioxide gas, and 5 mole of H2O. The observation is, first, the color of the fluid is blue, but the soot is formed. Second, we use oxygen test with basic cold KMnO4. So we use J C4H8 react with KMnO4, K5 manganate oxide, with basic cold KMnO4, and it will form C4H8O2 and MnO2. The observation is, purple color of KMnO4 will decolorize and brown precipitate is formed. Next, we use C4H10. We react with basic cold KMnO4, but there is no reaction, and the observation is, purple color of KMnO4 still remain.
Alright, I am Muhammad Laminazmi bin Muhammad Effendi, and my matrix numbers is 9200282. Okay, for the next question, sounds like this. Draw the structures of the isomer of C4H8 or butene, which shows geometrical isomerism. Okay, here there are two isomer of C4H8 which shows the geometrical isomerism, which is cis to butene and trans to butene.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafan bin Suhaimi and my number metric is 9200267. We are instructed to analyze the hydrocarbon chain in tomatoes with some references to do it. One of them is by referring to Al-Quran in Surah Al-Baqarah, precisely in verse 172. أعوذ بالله من الشيطان الرجيم يا أيها الذين آمنوا كلوا من طيبات ما رزقناكم واشكروا لله إن كنتم إياه تعبدون. O you who believe in the oneness of Allah, Islamic monotheism, eat of the lawful things that we have provided you with, and be grateful to Allah, if it is indeed He whom you worship. Tomatoes has component octamethyl. Dot contain 2, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 30 tridecane, or the general name is lycopene. Lycopene is an antioxidant-rich nutrient found in plants. It is the pigment that gives red, pink fruits their distinctive hue, such as strawberries, watermelons, and pink grapefruit. A small 100-gram raw tomatoes contain 18 gram calories, 30% of water, 0.9 grams of protein, 3.9 grams of carbohydrates, 2.6 grams sugar, 1.2 grams fiber, and 0.2 grams fat. Because of that, a single tomato can provide up to 40% of the daily recommended vitamin C intake. Tomatoes also contain vitamin A, which is essential for immunity, vision, and skin health. Vitamin K, which is good for bones, and potassium, which is necessary for heart function, muscle contractions, and maintaining a healthy blood pressure and fluid balance. And beside that, we can see the structure of lycopene. Okay, that's all from me. Thank you.